All right, here is a mathematics induction. So this is, I'll just fix this up. Oh no, I've got it up there. Chapter review 2, mathematical induction, question 1e. So here we go. So mathematical induction, remember the things we want to do is we're going to prove for n equals 1, assume for n equals k, prove for n equals k plus 1. That's basically what we're doing. So let's start with that. Let's prove for n equals 1. So for n equals 1, which is our base case, what we'll do is we're going to call it, let's call it Sn is that, okay? Equals 1 over 2 plus 2 over 2, 2 plus 3 over 2, 3 plus dot, dot, dot plus n over, 2n equals 2 minus, well, we won't even do that. We'll just do the left-hand side, okay? So we're calling it S just for series. So for S1, you actually have 1 over 2 to the power of 1, which equals a half. And if we have a look at the right-hand side, so the right-hand side, we have 2 minus 1 plus 2 over 2. So you end up with 2 minus 3 over 2, which equals a half. So left-hand side, therefore, true for n equals 1. So that's our first step. So let's call that step 1. Step 2 is, is where we're going to assume for n equals k. So the way we do that is I'm going to go, okay, my left-hand side, so I'll call it sk this time, is a half plus 2 over 2 squared plus 3 over 2 cubed plus dot, 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 n over 2 to the power of n. We're doing k this time. Sorry, I wasn't paying attention. K over 2 to the power of k equals 2 minus k plus 2 over 2 to the power of k. So that's step 2. So we've assumed correct or assumed true for n equals k. The next step, 3, we're going to prove for n equals k plus 1. Okay, so this is the one where we take a few more steps to do things, and we have to not make an assumption, we use an assumption. So this one here, I'll just go in green, that is our, what we would refer to as our inductive hypothesis, because we're assuming that's true, okay? So then we go to this step. So what we've got is we are doing sk plus 1. So that's going to equal a half plus 2 over 2 to the squared plus 3 over 2 cubed plus dot, 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 plus k over 2 to the power of k plus k plus 1 over 2 to the k plus 1 equals 2 minus, now we're going to do k plus 1. So I've got k plus 1 plus 2 over 2k plus 1. That makes sense? So I'm going to simplify that. Instead of k plus 1 plus 2, I'm going to get rid of that and just go k plus 3. I'm going to make that a little bit neater. All right. So, yeah. So there we go. So there's that. Now, what I want you to take note of, and this is where our inductive hypothesis comes in, that is from our inductive hypothesis. We've already got that up there. So what we're going to do is we're actually going to use that and replace all of that with this bit here. So I've now got equals 2 minus k plus 2 over 2k. Why have I got an equal sign on both sides? Do I want an equal sign on both sides? I probably don't, but yeah. No, that's right. I know what I'm going to do. I'm going to do just this left-hand side. Plus k plus 1 over 2k plus 1. So I'm just doing the left-hand side, okay? So now what I want to do is I want to get that Actually, I can get rid of the brackets. I've put the brackets there just to indicate I'm replacing it all with this. But I can ditch the brackets now. And what I can do is I can get it so that they are on the same fraction. So my right-hand side, I've already got the I've already got the 2 minus k plus 3. So that's what we're trying to get it to equal. So if I have a look at this, I am going to actually make this the same fraction. So what I'll do is I'll leave the 2. I'm going to change this fraction here. So I'm just going to come over to this left-hand side for k plus 2 over 2 to the k. I want to make it so that it's the same as this. So I'm going to multiply it by 2 over 2. Okay. Everyone happy with the, well, I say everyone happy with the fact that that will now look like it. I hope I'm saying that correctly because I'm really struggling with English at the moment. So I'm going to end up with, what am I trying to do? Oh, that's right. I'm going to end up with 2k plus 2 over 2 to the power of k plus 1 because I've got to the power of 2 again. So I've now got it over the one fraction. So I've now got 2 minus 2k plus 4 over 2k plus 1 plus k plus 1 over 2k plus 1. I hope everyone's cool with that. So if I do that, I've then got 2 minus, and I can add these two fractions together. So 2k plus 4, well, it's all going to be over 2k plus 1. So 2k plus 4 would get me, can't think, 3k plus 5. That's looking not very nice, but that's okay. And I'm going to minus 2. So actually, I'm going to leave that 2 out the front. Before I do that, I'm going to come back here, and what do I want to do? Actually, I'm going to pause. Sorry, I'm back. I've just deleted a couple of little bits. I just sort of had a bit of a glitch. Now I've just come back and I've gone, where was I? That's right. All right, so here is where we were, isn't it? I've taken the left-hand side because I've subbed in our inductive hypothesis. Yep, okay, cool. I know where we are. Awesome. So what we're going to do is we want to get a common denominator. So if I take our fraction, the k plus 2 over 2k, that is actually the equivalent of 2 outside of k plus 2 over 2k plus 1. I think I said that before because we've times by 2 over 2. So we get that. All right. So what I'm actually going to go back to is I'm going to go back over here, and I have got 2 minus k plus 2. What am I doing? 2 outside of k plus 2 over 2k plus 1 plus k plus 1 over 2 to the power of k plus 1. All right, cool. What we're going to do now is we're actually going to simplify this. I can actually get rid of that and get rid of that. I'll put that in there, and go 2 to the power of k plus 1 because we've got a common denominator. That's what we're doing. Alrighty. So next thing we're going to do is, okay, because we've done that, that's where I've got to be careful. That becomes a minus. Because if we expanded that, that would then become the plus. So that's where you've got to be careful. Sorry, I almost missed that. So when you do that, and I think that's actually where I made the mistake last time, that threw me. So I end up with 2 minus, and I expand this out. I get 2k plus 4 minus k, and that should actually be like that, minus k minus 1 over 2k plus 1, which gives us 2 minus k plus 3 over 2 to the power of k plus 1, which is equal to our right-hand side. And that's all we had to do. which means, therefore, proven via mathematical induction. So yeah, sorry about that. I don't know what the recording's going to look like with the break and all, but yeah, basically once you get to that point, once you get the common denominator, that is the big problem when you do that, just making sure that you remember that that's going to be a minus. Anyway, hope that helps. If not, we'll chat about it, I'm sure.